Hi everyone, good morning all. So today we are going to discuss the basics of an circuits and networks, and this subject is also called as network analysis. So let's try to have a clarity about the name of the subject, what is meant by an circuit, what is meant by an network, and why it is called analysis. It's very simple to understand. So the basic meaning of an circuit is nothing but if you have a single closed path, single closed path with active elements and passive elements. Let's try to understand what are active and passive elements. With active elements and passive elements. So in detail we will discuss about the classification of elements also. No need to worry. So single closed path means, for example, the active element here I am going to consider a battery or an voltage source of 12 volts, and this 12 volts is consumed by one resistor and one inductor. So this I am going to call it as R ohm, and this I am going to call it as L Henry. So in this 12 volts, I'm assuming this this 12 volts, the voltage at this point is 12 volts and voltage at this point is 0 volts, and current starts flowing from high potential to low potential. This I'm going to call it as current. Current I is equal to 12 minus 0 volts divided by R. So, okay, here I'm writing R plus the inductance. Okay, so generally you should not write down like this. So you have to write down in terms of if you take an AC supply, you can write it as XL ohms. All are in ohms. So that's how to write down. So here you can see here this voltage source is forming an closed path. Therefore, it is having a single closed path. If it is having a single closed path, then this is called as an electrical circuit. So that's what the meaning of an circuit. If like this circuits, we are going to have more. So this is this is inductor, this is one more resistor, and one more resistor is connected. Let's try to label this as some R1, this as some R2 and R3. Here this R2, R3 and L inductor is trying to form one more closed path. This is called as a one more closed path. This closed path is formed with the help of an inductor, resistor R2 and resistor R3. So this closed path we can call it as a closed path 2. If since a closed path, we can call it as an electrical circuit 2. So now how we are going to frame is group of circuits, we are going to call it as an network, or more than one electrical circuit, we are going to call it as an network. Okay, so or more than one closed path, this is closed path 1, this is closed path 2. More than one is there. More than one means it may be two closed path, or it may be three closed path, or it may be four closed path, or it may be infinity. More than one closed path if we have, then these kind of things, or these kind of more closed paths, we are going to call this as an electrical network. Why it is called electrical network means, here resistor, inductor, voltage source, all are electrical elements. That's why this is called as an electrical circuit. Group of electrical circuit is called network. And this network, what we are going to do is we are going to analyze. We are going to find out what is the current in this branch. I am going to label this current as some I1 current. I am going to label this current as I2. We are going to find out the current R2, sorry, current I2 and the current I3. So we are going to find this current. This is called analysis. Finding the current across a resistor, finding the voltage across a resistor is called analysis. So this is all about how to understand why the subject name is called circuit or network analysis. So this is very simple to understand. Circuit means a single closed path is formed with the help of an, so here what are the active element means, our voltage source which generates the voltage is called active element. The elements which consumes the 12 volts, which consumes the active power where we are going to call these elements are passive elements. So this is a passive element, this is an active element. We'll discuss in detail, you no need to bother. Okay. So voltage sources are called active elements, which absorb the energy are called as passive elements. Now coming to the classification. So this classification is very important in a gate point of view also. This plays a crucial role to understand. Okay. Let's try to go in deep. So first classification, today I am going to discuss about active elements. So first one is active elements. So what are different active elements? So active elements are nothing but these are elements which are capable of enhancing energy level, or which has the capability to deliver energy, or which deliver the voltage, are called as active elements. They have the capability to deliver the voltage, and this also have the capability to enhance the energy level. Indirectly, what I want to say is this can increase the voltage level from the voltage of V1 to V2. For example, it's like I'm acting like an amplifier. Here I have 12 volts and this voltage is enhanced to 24 volts. Here you can see here an additional voltage increment of how much is happened, 12 volts. This is called enhance of voltage, and here this is called delivery of voltage. Then these kind of elements are called as active elements. So then what is an active element? Active elements or have the capability to deliver or generate energy, or they can enhance the voltage level. So what are the examples I can understand to understand active elements? The examples of active elements are nothing but a battery. Next one is like a generator, AC generator, which generates an AC supply. In a battery, you are going to have AC supply. In a generator, you are going to have AC supply. These two are capable of delivering energy. Indirectly, they are going to deliver the output as an DC voltage or output as an AC voltage. So then these kind of sources are called active elements. So one more examples we can understand. So transistors is also an example of active element. Transistors and operational amplifier and vacuum tubes. You don't know these vacuum tubes in this generation. So these are also like perform the same action like transistor and operational amplifier. So the second fulfillment, what I told, is nothing but transistor and amplifier enhance the voltage level. Then these kind of elements are called as active elements. So the examples of active element is an battery, which generates DC supply, and generator which generates AC supply. And one more example in the part like an enhancing the voltage level is like an transistor, where it will act like an increment of voltage or step up of voltage. And operational amplifier also performs the, so this transistor and amplifier generally you can understand in the upcoming classes. These are also called amplifiers, which amplify the voltage level from V1 to V2. So if we take V1 as some 12 volts, it may be amplified as 24 volts by adding a voltage of 12 volts or scaling 2 times. These are the best examples to understand active elements. So this is all about active elements. And coming to here, how these active elements we are going to have. Okay. So generally these active, so first we'll try to understand these active elements and then we'll go for quadrant operation. Okay. And these active elements also have an negative slope. Let's try to understand in quadrant operation what is the importance of this negative slope. So directly I can teach now, but if you understand the basic, then you can go in depth of what is the importance of positive slope and negative slope. This is all about active elements. Now coming to the passive elements, what is meant by passive elements? So these are also the elements which absorb the energy generated by active elements. So already I told the active, what are the examples of active elements? It is like a battery. They are generating the voltage that is absorbed by the passive elements. So here we have the passive elements are nothing but a resistor and an inductor. This is R, this is L, this is C. So if you write down in AC form, we can write down this as R ohms. These are in DC form. Resistor, inductor, and resistor units are ohms. Capacitor units are also Henrys, and inductor units are Henrys. Capacitor units are farads. So this is the case of a DC. So to overcome this problem, we can express this in AC form also. In AC, you write down this is R ohms. If you write down this you can write down as plus J X L ohms, where this is called inductive reactance, or we can write down it as plus J omega L. So how to write down this omega L is J omega is nothing but 2 pi FL. So the ultimate units of this inductance is ohms, where we get simplified. That's why AC analysis is very easy than compared to DC analysis. Here you can write down it as minus J XC ohms. How to write down this XC is minus J divided by XC can be written as 1 by omega C. The ultimate units of this is ohms. We can write down it as minus J divided by 2 pi FC. The ultimate units of this is ohms. So if we express in ohms, the things are very simplified. This is like the inductor is acting like an resistor. The capacitor is acting like an resistor, where the analysis becomes simplified in the case of an AC network. So the best passive elements are nothing but resistor in the DC form, inductor and capacitor. If I express them in AC form, they all will be converted into ohms. So this is all about active and passive elements. So here these passive elements are going to exhibit a positive slope. So they have the characteristics of positive slope in what, in xy plane. So if you consider the xy plane or this voltage and current plane, then they are going to exhibit a positive slope. Let's try to understand how they exhibit a positive slope. Already I told active elements exhibit negative slope, passive elements exhibit positive slope. Okay, so I'll try to review the things. Circuit means single closed path is called circuit. Group of circuits is called network. This is also called network analysis. The purpose of the network analysis is to find out the current across a resistor or voltage across a resistor is called network analysis. So this is what the meaning of a circuit, network and analysis. Active elements are, they have the capability to deliver the voltage or energy. These are called active elements. Passive elements means they have the capability to absorb the voltage. The examples of active elements are a battery, generator, or voltage amplification, transistor, amplifier and vacuum tubes are the examples of active elements. Remember a point, they exhibit negative slope in xy plane. This xy plane we are going to call it as a voltage and current plane. I will demonstrate it. So passive elements examples are RLC in the case of a DC supply. In the case of AC supply, they act as R ohm plus J omega L ohms minus J omega C ohms. So this will directly converted into C. Therefore, in electrical engineering, rather than DC supply, the AC supply analysis is very simple. Why? Because this inductor we are representing in ohms, this capacitor we are representing in ohms. Automatically, complete network is like a resistive network. The analysis becomes very simplified. Now, the concept what I told, the passive elements have negative slope in xy plane. Or what is this xy plane, or what is this voltage and current plane? So in order to understand in detail, let us try to draw a plane. So these questions are important in competitive exams like GATE, PSUs and different. So directly they will represent a plane and they will ask which quadrant active elements are there, which quadrant passive elements are there. So already I told I'm going to consider this x-axis as an current and y-axis as an voltage. And I already told I will explain the linear and non-linear. Currently I am assuming I have a resistor which is having a linear graph like this. So with the increment of voltage of 1 volt, with increment of voltage of 1 volt, they are generating a current of 1 ampere. With increment of voltage of 2 volts from a voltage source, they are generating a current of 2 ampere. With an increment of voltage of 3 volts, they are generating a current of 3 ampere. With an increment of voltage of 4 volts, they are generating a current of 4 volts. Here 4 amperes. Here you can see here I am taking R is equal to 1 ohm. So current I is equal to V is how much? 1 minus 0 by R. R is nothing but how much? 1. Therefore 1 by 1 is how much? 1 ampere. So similarly the current I2 I am drawing. So current I2 is voltage applied is 2 volts by 1 ohm. So this is nothing but 2 amperes. So current I3 is equal to 3 volts minus 1, that is equal to 3 ampere. So similarly I4 is equal to 4 volts minus 0 by 1 ohms. This is 4 ampere. You can see here the voltage and current magnitudes are gradually increasing. This gradually increasing I am going to show like a dotted point. If we join all this dotted line, then I can say that these elements are called as linear elements. These linear elements examples are our resistor, inductor and capacitor. All will exhibit same linear characteristics. With the increment of voltage and with the increment of voltage, the current also will increase. I mean voltage is proportional to current. So the voltage you increase with the voltage source, automatically the current in the network or the circuit may also increase. Where the relation is directly proportional relation, then this kind of elements we are going to call like a linear elements. So these elements are called linear elements. Now, sir, what happens here? These you can see here. If you find out the slope here, how to write down the slope? Y is equal to mx. M is equal to y coordinates by x coordinates. Here, what is the y coordinate? Voltage. So 1 volt. What is the x coordinate? 1 ampere. So V by I is nothing but R. So we have the formula current I is equal to V by R. We require R. R is equal to V by I. So V by I, how much you are going to get? 1 ohm. You see here, this 1 ohm is indirectly the slope of the line. The slope is positive or negative? The slope is positive. If the slope is positive, I can say these elements are passive elements. Just remember, already I told if the slope is positive, then these elements are passive elements. So what are the passive elements? We already discussed. R is a passive element, L is a passive element, C is a passive element. So they will show in the competitive exam, they will draw a graph and they will ask, they are lying in first quadrant. The elements lying in first quadrants are which elements? Passive elements. Very simple. Why? Because the slope is positive. And you can see here, here also you have positive current, here you are going to have negative current, and here you are going to have negative voltage. So now when you plot an independent value here, okay, so here you have minus 2 amperes with a voltage of minus 2 volts. Let's try to find the slope here. Slope m is equal to y by x. So what is the y-axis? Y-axis is minus 2 volts, x-axis is minus 2 ampere. So voltage would cancel out. Voltage by current, we are going to call it as a 1 ohm. And you can see here 1 ohm, I mean the slope is 1. I can say here slope is positive. If the slope is positive, then you can say here if the slope is positive, then these elements are passive elements or energy consuming elements. these elements are passive elements. Those passive elements are again R, L, C. Very important. And coming to the next analysis, let us try to draw a dotted line. So you can see here, if the elements are there in first quadrant as well as third quadrant, okay, if a graph is shown in first and third quadrant, you can call these elements as passive elements. So here we have the passive elements, here also we have passive elements. The passive elements are, what are the passive elements? A resistor, inductor, capacitor. Resistor, inductor, capacitor. These are called passive elements. These are called passive elements. Now come to our next analysis. So same graph I am going to draw here, so which will create an clarity to you. So I am going to have a dotted line which is traveling in which coordinates? Let's try to mark the coordinates. The dotted line, so this is traveling in second quadrant as well as in fourth quadrant. So what about these elements? So here when you find the slope, and if you see here, if you get a straight line, you can conclude straight line is there means these elements are linear elements. These elements are linear elements. All linear elements are nothing but RLC. Now let's try to find the slope here. What is the formula for slope? M is equal to y by x. What is the y coordinate here? So y coordinate is, let's try to mark this two parameter. What is the y coordinate here? Y coordinate is positive 2 volts and x coordinate is minus 2 ampere. So voltage by current, this is nothing but what? Ohms. How much ohms you got? Minus 1 ohm. What is the slope here? Slope is negative. If the slope is negative, I can say these elements are active elements. So these elements are active elements. What are active elements? A battery and AC generator. I mean, they can generate a positive voltage or they can generate an negative voltage. That is also possible. If the voltage direction is reversed, the current direction is also reversed. Okay, so that's why we need to have a negative, I mean the change of voltage from positive to negative or change of current from positive to negative. But in this scenario you can see here they are generating some positive voltage, the direction of current is reversed, therefore they have negative slope. Similarly in this quadrant also the same will happen. So in this quadrant if you find the slope, M is equal to y by x. So consider these two parameter. What is the y quadrant? So slope is equal to y by x. What is the y quadrant? Minus 2 volts, but current is positive here, 2 amperes. So voltage by current is nothing but minus 1 ohm. I already told, if you get the slope as negative, negative slope is there. If it is a negative slope, then automatically these elements are called as active elements. So here you have which kind of elements is active elements. So active elements will be there in quadrant 1 as well as quadrant 2. So in the competitive exam, they will show you a graph and they will draw a line and they will ask, if you just fix that, if they drawn a graph from second quadrant to fourth quadrant, then you can say that these elements are active elements. If they drawn a line in first quadrant and third quadrant, then those elements are passive elements. So just remember, passive elements have negative slope and passive elements have positive slope and active elements have negative slope. So this is very simple to understand. I had already drawn here. So passive elements have positive slope and active elements have negative slope. So this is very simple to understand the quadrant operation. Okay, this quadrant operation is called current and voltage axis. So in this they behave like this. So when you see an element in first quadrant and third quadrant, those elements are passive elements. What are passive elements? Resistor, inductor, capacitor. If you see the elements in second quadrant and fourth quadrant, those elements are active elements. What are those active elements? A generator or an battery. So here we have what kind of slope? Here what kind of slope we have? Positive slope. Here what kind of slope we are going to have? Negative slope. So passive elements have positive slope, active elements have negative slope. So this is all about active elements and passive elements and their quadrant operation. We will continue the next one with unilateral elements, bilateral elements, as well as followed with different types of recurrent and non-recurrent networks. Thank you for watching. If you are watching for the first time, if you feel the content is useful, please give a like and please share with your friends. And if you have any doubts in this session, let me know in the comment section. If you are watching for the first time, just subscribe to my channel with the name KV Tulasi, yours obediently Ram. We'll meet in the next session. Thank you for watching.